Okay. All right. So we're going to get into stored procedures. We're going to review a little bit about stored procedures first, and then talk about what are often called the standard ones, right? So just to recall a bit of the material that was covered last week, a stored procedure is just another database object, something we create inside the database, right? Fancy word here, named collection of TSQL statements, okay? Basically, these are the building blocks of most database applications are the stored procedures, right? So we can encapsulate repetitive tasks, things that we're going to ask the system to do over and over again. We can work with variables, okay? We can have conditional execution, decision structures, ifs, things like that. Basically, any of our programming features are all available in stored procedures, right? They are usually used to carry out operations in the database. You know, things that we're going to do, maintaining data, insert, update, delete, all that kind of stuff, right? They can take input parameters. Now, unlike a function, though, they don't just return, like a scalar function returns a value, right? You can return a status, okay, and, you know, possibly a message, but other than that, basically all you can do is you return data. You get a result set. Now, you don't have to return data from a stored procedure. It can just carry out a job and say, hey, how many records were affected by, you know, the job you asked me to do, things like that, right? So they're very flexible. There's lots of things that they can carry out for you, right? Basically, it's just create procedure, like most of our things, create function, create view, create whatever, create table, right? So create procedure, a name for the procedure. Optionally, there's a parameter list, okay? And then the keyword as is followed by the actual statements themselves, right? And that's really all there is to it. The name specifies the name, parameter list isn't required, and there can be both input and output parameters, okay? You've used output parameters before. Basically, you have to have, if you're going to call a procedure to execute and you have an output parameter, you have to have a bucket to throw the result in. In other words, you have to create a variable to pass when you call the procedure so that it can output a value into your variable, right? Okay. So that's just a quick review of what procedures are in general. But, you know, as with so many things in life, after a while, whatever your trade or whatever it is you're working in, there are certain things that you find are needed over and over and over again. Common things that are required. Well, in any application, there are common stored procedures that we end up creating something similar to this over and over again, right? Because that's just what the situation calls for, okay? Returning data. Sometimes we'll have, very often, stored procedures for returning data. Now, it might be from a table, or it could be a view, right? Sometimes you're returning a single record. Like, go get me customer, often by ID such and such, right? And boom, all right, the stored procedure returns that one customer. Or it might be, go get all the records, okay? Or perhaps a filter is going to be applied, okay? All the customers in Welland, for example, right? You might filter by that area in some way, shape, or form, whether it's by a postal code range or who knows what, right? Or just a lookup value for the city, things like that, okay? So basically they're data returning stored procedures, okay? Along with that, one of the specialized ones I'll draw your attention to is often we call them lookup stored procedures. Say, again, you're working with addresses, right? And, you know, part of the address is you have a foreign key for the province, right? In a relational database, we don't store the whole name of the province in the address record, usually, right? We'll have a little, maybe just an integer that relates to the primary key for the province. And that's all we store in the address. If we need the name of the province, we'll go to the province table, right? So often you're filling out address information on the computer screen. You come along to where you're going to select the province for the address. What does it usually look like? A drop-down list, right? That's commonly how it's presented on the screen to us as users, right? So that's a select element if it's an HTML page, or a drop-down list if it's another kind of a Windows form application, and so on, right? Well, the data to populate that lookup, that drop-down list, okay, often will create a stored procedure just to give us that data itself. And it's very simple. It's usually just the identifier, which is often a primary key. In many cases, it might just be an integer, okay? And then the actual display text, what you're going to show in the drop-down list. And that's all that little very specialized lookup stored procedure will return. Okay, often just a primary key and a summary field. But the other key thing about that is you want it sorted, right? Have you ever gone to an application where the drop-down lists aren't sorted? What a frustrating thing that is, right? You start typing letters and you expect to jump in the list, right? And if it's not sorted, that doesn't work very well. Okay, so those are different kinds of common data returning stored procedures. Okay? Then we have the action queries, insert, update, and delete. Now you know by now that of course you could do a bulk insert, right? Or update all the records for people, again, say in Welland, right? Things like that. Deleting, yeah, you can delete a bulk, everybody who doesn't like my songs. No, sorry, whatever, right? You can do bulk deletes as well. But in a business application, the typical kind of application that you're going to do most often, we're usually working with less than 2 records at a time, right? So you insert 1 record, you update 1 record, you delete 1 record, right? So we often, in terms of these common or standard stored procedures, will create ones that look after those individual actions on 1 record at a time, insert, update, delete, right? Okay. So in terms of the select procedures, I kind of went over this quickly, but to break it down, select with no restriction, no where clause, so you might just go select all the data, right? By the way, what we'll often do is instead of going directly to a table, our selects will be based on a view, especially if there are related entities. In other words, like those lookups, like for an address of the province, again, to use that as the example, right? So you make a view that pulls the information together based on that primary foreign key relationship. And there might be multiple ones, right? Multiple lookups. But you pull it all together in a single view for easy presentation of the actual data, right? So that might be what you base your select procedure on as well. Okay, select by primary key value. The next most common thing, go and pick that one record. So maybe it's a customer. You're going to pick the one customer whose information you want to pull up in a form on the screen, right? So perfect use for selecting an individual one, usually by the primary key or some other unique identifier, right, if it's not the primary key. Okay. And then we'll often have additional select procedures, right? If we regularly filter by different criteria, right? And we're going to later on, we'll talk about select by X, I sometimes call it, selecting by multiple criteria. We'll learn some tricks to basically nullify a filter if we don't want to filter by city, but we want to filter by area code, right? Or vice versa and things like that, right? We'll look into that. So basically you have the minimum, you have those 2 standard stored procedures. Select everything, select one, and optionally additional filters. Okay. Then we have our data manipulation language stored procedures, right? The insert procedure, okay, usually besides just getting the job of inserting the record, will return if there's a automatically or database generated primary key, right? And you've done quite a bit of work with integer identity primary keys. Am I correct? Where you set up the table so it automatically generates a new integer value, starts at 1, 2, 3, and so on, never reuses them. So if you delete a record, it'll never recreate, right? If you delete record with ID 4, that's gone forever, right? That's one of the most common. Okay, there's also other types of database generated primary keys as well. You can have GUIDs, globally unique identifiers, those big long, like 18, 20, depending on how your system's set, right? Those big long gobbledygooky looking primary keys. Okay, they're another option there. But whatever way if the system's generating the primary key, you almost always want your insert procedure to return that information, so that when you're done inserting the record, you have that for the next steps that you probably want to do, right? An update, okay? Again, we're focusing on 1 record at a time in all cases here, right? Here's where we often get into version control. Now, you've talked about the use of a timestamp field, correct? Talked about timestamps already? A couple people nodding. Good. Okay. If you haven't thought about it for a while, that timestamp parameter, sometimes called a row version, okay, is something that is automatically generated by the system. Remember, there are two approaches to concurrency control. You can compare all values, right? So if you've got a copy of a record, you come back and you want to update it, okay? If you have the old values and the new values, you can compare. See if anything else has changed from the copy you received, right? That is where you could catch if somebody else snuck in, dirty thief, sneaking in behind you and modifying the record while you were working on it, right? Well, that's what you want to avoid, is overwriting the record, not being aware that somebody else has changed it in the meantime, okay? So you can compare all values, but that's a lot of work and a lot of data to carry back and forth. So most situations will create a timestamp or row version, something that is automatically changed with every update to the record. Then we just have to compare that one thing, right? So that's what we'll do for version control. We'll compare the timestamp parameter of the value passed in with our current timestamp. We'll do that on the where clause, and that will help us identify that, oops, somebody else has been messing around with this record in the meantime while I was working on it, right? So that's an important part of an update stored procedure. Delete, okay? You might have version control, because you might decide that, you know what, if somebody else edited the record, then maybe I shouldn't be deleting it after all, right? Maybe there's a new reason why I would consider not deleting this record. So that's a design decision. There's no right or wrong there, okay? So you can do the same thing. It's just a matter of adding the where clause to compare timestamps, right? But, you know, in my experience, much of the time, delete is just delete, okay? If you're going to delete the record, we don't worry about version control. And, you know, there's no right or wrong there. It's up to whoever, what the boss tells you to do, right? Okay, so that gives us 5. Select all, select the primary key, and then insert, update, and delete. 5 standard stored procedures, okay? Now, one thing, a little thing that comes up in these stored procedures is we usually take time to set our no count option. Have you looked at no count before? Sometimes it comes up earlier on, that's why I ask. Basically, data returning procedures, when there's a result set returned, we would set no count to on. Now, what does no count actually do for us? Well, you might have noticed whenever you execute a procedure, if you look down in the bottom region there, there's 2 little tabs. One says results and one says messages, right? The messages are usually pretty simple. The most common one is how many records were affected, right? So yeah, 1 record affected, 0 records affected, okay? Or if there's multiple, then it'll show you how many there were, right? Well, the point is, why bother plugging the network pipeline, so to speak, with that message if you're getting the data anyway, right? I can look at the data, the result set, and I can see how many records there are. So I don't need to clog up the pipeline, so to speak, with those messages as well. So we'll set no count to on. Now, whoever decided to put no count, you know, why not say set count off, right? But it's reverse logic, so it's always confusing for me. So don't be surprised if you feel confused. You gotta think, okay, I want to set no count to off or do no count to on, and you gotta think, okay, no count on means we're suppressing those extra messages about how many records were affected. For action procedures, our insert, update, and delete ones, it's the opposite situation, right? They don't necessarily return any data, right? So it's the message we're looking for. We want to know, did it work? Did we actually insert a record? If it did, by setting no count off, we allow that message to come through to say 1 record affected, right? And then we know the insert worked, or the delete, or the update, whatever the case is, right? Because often, you know, there's no error message raised, right? It's just a matter of checking, did it work or not, by checking the message itself. So it's a little thing, but it's part of our approach, the universal approach to our standard stored procedures, to either set no count on or off, depending on the type of procedure it is, okay? As I say here, client-side objects depend on those messages for rows affected, okay, to know if there was success or failure on an action query, right? You could communicate it in other ways, but okay, there's no real performance difference, so just stick with this. All right, so what I'm going to run through now are some recipes. Hey, if you're going to do something in a standard approach, it's good to have a template or a recipe to follow, right? So that's something that we usually end up looking at. So they're guidelines. It's not the only way, but these are pretty universal guidelines. I didn't make these up, okay, but I follow them, right? So they're based on a few assumptions that we're going to use as we look at these recipes or guidelines for creating these standard stored procedures. I'm going to assume for now that every table has an integer identity primary key, always called ID, okay? You know, in some databases you'll see it'll often use the table name ID, things like that. That's fine too, but you know what? In my programming experience, I find usually the best approach is just say ID, right? And you'll see, especially next term as well, when you start working with things like Entity Framework Core and so on, different tools that give you sort of an extra layer between you and the database, right? Then it works very well. Timestamp fields have been added for concurrency control. We'll assume that as well. And at the very least, for audit fields, we have updated by and updated on, right? You've talked about created by, updated by before? Okay, yeah. All right. So if you also have the created and updated on, okay, then we'll set them to the same values as the updated fields on insert, right? Okay, so those are our basic assumptions for these recipes. All right. And of course, we want to write procedures to match the data you have in your tables, of course, right? So here we are. Here's our standard select all, right? Create procedure. Oh, by the way, what is USP? Why would we have that prefix? What is SP underscore? SP stands for stored procedure, yeah, but that's reserved. No, don't use SP underscore. Built-in stored procedures, and there's dozens and dozens of them in every database already, okay? Especially in the master database. There's all kinds of stored procedures there, and they all have SP underscore as the prefix for them. So you wouldn't want to confuse things by using that yourself, right? The U stands for user stored procedure, right? Okay. After that, you know, I typically will use common naming conventions so that I'm consistent and I can remember easily, right? So the name of the table, or entity really, right? Select all, right? And then there's no parameters required because we're just returning all the records. So we set no count on, we select all the fields from either the view or the table. In practice, especially if there's any relationships to a table, you'll always create a view first and base it on the view that is then kind of denormalized. It actually has all the lookup values right there in each row and things like that, right? And that's basically it. Select all the records from the table, okay? There's no where line, and then away we go, okay? All right. Now, oh, I missed one. I went too quick. Select by the primary key. So here's our recipe here, okay? What have we added? We've added one parameter, okay? Again, we're going in the assumption we have an integer identity primary key, so we'll have @ID. Of course, indicates it's like a variable, okay? A parameter in this case is just a specialized variable. And we have to specify the data type whenever we declare a variable, right? Okay, so that's it. So in terms of the name, and again, be the entity, whatever it is, select by ID, right? See? I'm taking away so much of your freedom in terms of how you name things by following these recipes, but it helps to be consistent. And then it's basically the same. We set no count on still. We select all the fields. The only thing we've added here is the where clause, where we're just looking for the one little record that matches our primary key, right? Returns a single record, and away we go. Now, if we're going to add an additional optional selects, okay, typically they're for foreign keys, right? That's the most common thing you filter by. If you have a foreign key, again, I'll use the address example, okay, where city, right, is a foreign key, and you want to filter by everyone in a given city, then away you go, right? So when the foreign key is equal to the flag value, it returns true. So that's one way we can kind of cheat and say, hey, we don't want to filter by anything this time. We don't want encode to have to worry about changing and using a different stored procedure on the fly. We can reuse this one stored procedure and basically remove the filter by using a flag value. Okay? Now the flag value must be a value that would never exist in the actual data, right? Otherwise, it's not a very good flag, or you'll get false results sometimes. So we'll create a procedure. Again, select by the foreign key. Now, you can actually name the foreign key if you want for clarity here, because you might have multiple different ones as well, right? So then we have our foreign key value. Now again, if every table has an integer identity primary key, the foreign key is going to be integer as well, right? That's how you relate them together. The foreign key in this table matches the primary key in that one. That's the relationship is built on that. So it'll be an integer, right? What's a good flag value you think you might want to use, by the way? If an integer identity primary key on the lookup table or the related table, what's an integer value that would never be generated as an identity?
-1.
Sorry? -1. -1, yeah, you could use that. But the thing that jumps out to me is 0. Because the first integer identity created is always 1. 1, 2, 3, 4, and up, right? So 0 makes a great flag value, although in some systems you would use -1. But with SQL, we normally use 0, right? And it does the job. So our where clause is looking for a match between the parameter and the actual foreign key, or, okay, the foreign key matches our flag value, which we usually will just use 0, right? That way, if you pass in 0, you're not going to filter by anything because that's always true. And with a or, right, the whole logical expression is true if one side is true. And since that side is always true, basically all data is returned. So you might say, what's the point? Why not just call the select all procedure? It probably would be a little bit more efficient, but believe me, it's a real pain in the rear end in developing the front end application if you have to switch stored procedures, right? This is the easier way. Just pass 0. Okay. All right. Now, 3 more recipes to go, then we'll take a break, okay? Insert procedure. We need input parameters for every column, except, of course, auto-generated ones, right? So we have all these parameters, and the data types, of course, should match the data type of the field in the table itself, right? Updated by, okay? We're going to have a parameter for that, and I'll usually set a default value here. Sometimes you're going to develop this before the client application is actually even configured and ready, right? There's no login system yet for them to actually say, this is D. Stovall, or whatever is the user, right? So we'll usually set up something like unknown so that you can actually carry on with your work while you're waiting for the client application to be ready to provide that information, right? And remember, with an insert, the other thing we want to do, we want to provide as output the newly generated primary key. So that's why we have our @ID integer as output parameter, and we identify an output parameter with the keyword output, right? By the way, in SQL, when you call or execute a stored procedure with an output parameter, you have to have a variable there to receive the value and the keyword output as well, right? So the system clearly knows this is here to receive that outputted value. Okay, so then we're going to set no count to off, right? Because we do want to send those messages about how many records were affected. And then we have our standard insert command. Now you learned about insert commands earlier, right? So we're just going to insert into our table, okay? We don't normally insert into views, although that's something you can cheat and do if you set up triggers to handle that situation, but we'll just insert into the table all the fields, including the updated on and updated by information, right? The values, of course, are going to come from our different parameters, okay? For updated on, we'll usually just use something built in, like getDate, returns the current on the server, the system date and time. So that'll automatically say, okay, this was updated, and that's the best way to do it, based on the clock on the server itself. And then our updated by value, which could be a parameter value, a real one passed in, or our default of unknown, right? And that will finish the insert. Whew, job done, but not quite. Because remember, we want to return that newly generated primary key value. So we finally say, hey, we'll select a value into that parameter, and that's all we have to do is make sure it has the right value when it returns. So, have you talked about identity and scope identity? Okay, good. All right, so yeah, scope identity, within the scope of the current batch, right, will return the newly generated identity value. Okay, and our where clause, well, what if the insert didn't work? There was some constraint or a check constraint or something like that that caused it to fail, right? Well, by checking our row count is how many rows were affected. If it's not equal to 1, then we know it didn't work, right? So there's no point trying to get scope identity because it didn't generate a new identity value. So our ID will just be the default value of 0, right? And that's okay. Okay? It's a way then the client side can check, oh, if the output value for the new primary key is 0, then that's another way I know, besides the fact that, of course, my row count, return the number of records affected, would be 0, right? Okay, so that's our recipe for an insert. Update, only slightly different, really. We're going to update the table, and we have our parameter list. We have to make sure we have the timestamp value, right? And then our updated by will handle in the same way, okay? So we set no count to off, we update our table. You've done update SQL commands before, setting all the fields according to their matching parameters. Updated on, we use getDate, just as we talked about a minute ago for insert. Updated by, handle it the same way. But our where clause here, of course, we want to make sure, of course, we're updating the right record. So that's where our primary key matches the ID. And this isn't an or. Both have to be true. We have to match the primary key, and the timestamp has to be the same as it was when we got the record that we're updating. If it's been changed because somebody else has been in the system and updated it, then we don't want to try and overwrite it because that would be a concurrency error, right? Or a possible error caused by lack of concurrency control. Okay, so that's our recipe for update. Easiest one is delete. Okay, we're not going to necessarily, we can or don't have to add the timestamp. Depends on what we're directed to do, right? If it's up to you, then you can choose. Okay. Basically, just we pass in the primary key and the timestamp. If you're not going to worry about concurrency, you don't even have to have that second parameter, right? Set no count off, so we do return the number of records affected. Delete from table where the primary key matches and the timestamp matches. Again, optionally, if you are going to do concurrency control. Okay, that's it. Now, just to quickly mention a couple more things, right? We're almost done the PowerPoint. Other common procedure types are list style stored procedure I talked about earlier, okay, where we just return two things, the information to show in the drop-down list and then the internal value for each one of those, usually the primary key value, right? And our filter by foreign keys, okay? And our select by many criteria, but it's basically the same as what we looked at for the code for the foreign key, just that we have multiple parameters. Each one has a flag value of some sort, although it's a range of dates. Okay, our trick there is usually to use the maximum and minimum date of the system, because everything will be between that, right? Unless you have specific dates you want to work with otherwise. But we'll talk more about select by X later on. Okay, just to quickly look at a recipe, an actual recipe for the list style stored procedure, right? Again, it just returns data. There's no parameters needed, okay? So we set no count to on. We're getting data. We don't need that message as well. Selecting the ID, and usually just something. We'll often concatenate a few things together, not necessarily, okay? It might just be maybe one of the columns or fields of the table tells us everything we need to know to show, okay? It could just be the city name, for example, and that would be fine. But sometimes we'll put multiple pieces of information together for a better display, so the necessary information is easily available to the user in the drop-down list. So often I'll call that like a summary as a name for that extra field that we're putting together. And we'll also do the order by, okay? Make sure it's in order as well, okay? And that's it. Okay, we're at the end of our discussion, okay? So standard stored procedures, okay, might in the end be the only objects that are accessible to the client. in terms of security, you don't let them even access the tables directly, right? They can only work through your stored procedures, and that's often the way things get set up in the end, right? And then you can add more stored procedures, for specific needs as required, right? But this is often the foundation of what you eventually do in your database to support your client application. Later in the course, that's what we're going to be focusing on, is making client applications that work primarily with our standard stored procedures. Bada bing! Okay, so I'll stop the recording. Ooh, that was fairly long.